There we go. Welcome everyone. And today on the topic, we had a couple of points. The first one is non-intrusive data-driven debugging, and the second one was discussing inputs, virtual, physical, multiplayer, local multiplayer. And of course, if you have any question, don't hesitate to ask them, and I will be happy to answer any of them. So starting right now, I'm not able to see Discord anymore. So don't hesitate to ask questions out loud if you have any. The first point, to illustrate it, I'm going to reuse the little test I was using in the last session, which is this here, where I already have like characters that comes with randomization, multiple layers, and that are controlled with different inputs. So right now I have like a player 1 and a player 2, and they can just move around, idle or run. And we're going to see how we can add like some debug information. And that's interesting because these characters are randomly generated with all their layers coming from like a lot of different possible inputs. So we're going to see what we can print under them. Let's start with this. So the first, I'm going to copy paste because I already tried to do it last night, and it's going to save me a bit of time. So here we go. We're going to add a label here. Up. And going here. So the first thing, well, yeah, actually, let's start the first thing. And why is it 3? I can't. I'll see you later, okay? Okay. So sorry about that. So yeah, going back to here, this is our main config file. We have an entry that's going to include a file called dev.ini, and that's just a name I picked, and it's usually a file that I will not submit to my Git or Perforce or Mercurial repository. It's just a file I have locally only. Mean that if you run the game without having that file on your system, it's just going to run normally. But if you have this file, given that I put it after my main config file, it's going to override some of the configuration, and that's how you can like do like very specific changes to add like debug information, for example, or to add like cheats or things like this. And this file here right now is currently empty, but even if the file did not exist at all on disk, so let me actually just remove it. I'm going to delete it. Even if the file does not exist, it's not going to prevent the game from starting. It's actually going to start normally, just not going to load that file. And we can see it when we run the debug one. There's a message saying can't load dev.ini, invalid file not found, and you have it here. And that's just, the file doesn't exist, but it will not prevent us from starting and running normally. So let's go back. Now I'm going to save this file on disk again, and I'm going to put some content in it. So what I'm going to do is I'm going to create a base class named, base section named label, and it's just to put like common properties I'm going to reuse for my debug information. So I'm going to put the pivot for label at the top, so at the center top. And I'm going to say that this label has a graphic, it's itself, and it has a text as well, and it's itself. And that allows me to have like a common base for all my labels. After that, my base character section, which is used by my character class, which was here. So every time something that inherits from the character section is created, we get an instance of the character class, meaning that it can be controlled with inputs. I'm going to extend its child list. That's why there's a plus equal here. It means it's going to take the current child list and it's going to add an extra object, an extra child, and it's going to be named enim label. Enim label is just inheriting from label. I'm just give it like a color, and I'm going to give it a track, which is itself, and it's a looping track. And that track is going to run every single frame. That's why it's 0, so there's no delay. Every frame is going to run, and what it's going to do is that it's going to get the current sibling of that object, it's going to put it on the stack. It's going to retrieve the animation, the current animation thing. The true means get the current animation. And it's going to push that on the stack. And lastly, it's going to update the text of that current object, so the anim label object. And it's going to say anim and whatever was on the stack. So basically, what it's going to do, and we're going to see it by running it here, that under our character, we can actually see the playing animation by it. And you can see that it changes depending if I'm moving, and in all different 8 directions, you can actually know exactly what's going on with your character. So already we have information that was easy to add. There's no code changes. It's a bit of data that's just in a local file. It's not going to affect your build, I mean that your game, you can still distribute it the way it is. It's just going to be local to your machine, and it's just going to be like extra debug information that can be useful when, I don't know, like for example, you're debugging animations. What if now we wanted to have a bit more information? Like for example, we know that those characters are made of multiple layers. There's a base layer for the body, there's a top layer for the top part of the clothing, there's a bottom layer, there's like a hat, there is facial hair for the male but not for the female, and there's a weapon. So if we wanted to output all this on disk, we're going to actually do basically the same thing. But instead of this time asking for a new child on the character itself, we're going to do it on every layer, and every layer inherits from this animation set, which is character anim set. We can actually go see it here. It's the character animation set. That's here. And this is what is being used for all the layers to place the animation in all the directions and so on and so forth. That we actually saw during the last live event. So, and similarly to what we did with the animation label, the character animation set now is going to add a new child to it, which is called layer label, and this one is going to be colored green. And you can see that this property is called just label color, which is not a property that Orx will recognize. So it's a property that we're going to use ourselves, and you'll see why in a second. Our layer label is just inheriting from label, so it's just going to be a text. And this time, upon creation, because we do not need to run it every single frame, I mean, the name of the object is not going to change every frame, contrary to the animation. So upon creation, we can actually fill in all the data we want. So basically, we're retrieving the owner, so that's the parent. So like, for example, the player 1 or player 2 right now. We're going to push its name 3 times on the stack. It's because we're going to retrieve 3 information from its config section. The first information we're going to retrieve is the name itself. So we're going to change the text of our current label with a name that has been pushed on the stack. Then we are going to retrieve the position of the label, and we're going to update the position of our current label with this. That allows us to actually not have all the labels on top of each other, but have them like spread out around the character. And lastly, we're going to also retrieve the color and going to change the color. So instead of being like a set properties, we were just going to retrieve that upon creation, and we're going to set it on the object. So now all we have to do is create those properties for each layer. Like for example, right now, if I wanted it to work for the base one, we say that the layer that's going to be for the base is going to be in color red, and the position is going to be above the character. And as you can see, those properties come from the parent. So the parent are the base, they are here, the base, the bottom, the top, the facial hair for the male, the hair, the head, and the weapons. So in those base sections, we're just going to add whatever we want to use. So right now I'm adding one for the base, and if we start right now, you're going to see that. Oh, that's not working. So I forgot something. What did I forget? Let me see. So we have the character animation set that getting a label, and the layer label is here. It's on create, and we have the base. I actually tried to do that last night to make sure that we would not make any mistake, but apparently I still made some mistakes. So unfortunately, I didn't sleep much last night. I'm a bit tired. Hopefully, I will be able to spot that very quickly. So let's see. So what I would expect by running this, there we go. Okay. So I guess I didn't do a good copy paste the first time. So as you can see here, for each layers, we're going to define a position where to put the label. And here we only overridden the base in red, meaning that all the other one is going to use the default one, which is green. And you can see that for each layers, we can see the name of the layer. So like, for example, our player one is using currently the female base musketeer. And she's also using the female top musketeer, but also the female air necromancer, the female head beastmaster, female bottom beastmaster, and the female weapon dagger main. And when we reload, we get other random combination, and you can see that we can actually know exactly which combination they are going to be used right now. Like the male is using the top witch hunter, and the female is using the top necromancer, and so on and so forth. So again, this is extra debugging information we have on screen, and we didn't have to modify like the codes. And in the same way, we could add any information we wanted. Like, for example, we could add like their position in the world. We could add any data like their health points or whatever you want, like very easily by just adding children object and having a bit of a few commands running on the onCreate of those objects to retrieve characteristics that you want to express. Like here, the characteristic we want to express is the name of the object itself. But in the animation, what we wanted to express was the name of the animation. And if you have your own data, you can actually add your own command to retrieve whatever information you want and format it the way you want, and just display it on screen like this. But right now, the labels are very like basics. Like, let's say if we're going to take the player one, caps lock, the player one, and we're going to make it turn around itself. You can see that the labels are moving as well, and that's not exactly something that you would expect from like debug information. And same thing if we were like to scale it. So object at scale 0.2, you can see that it's tiny and the labels are not readable anymore. What we can do for this is that we can say, okay, we're going to ignore properties from the parent. So we have we are going to ignore part of the transformation from the parent. There's a property called the IgnoreFromParent. And here I'm going to say I want to ignore the scale from the parent, and I also want to ignore the rotation from the parent, for example. And if I do this, and also like the position rotation, so that if I start it again, and I do the same thing, now if I change the scale of my object, of course, I need to find it because it's a new one, player one, set scale, and now if I change the scale of my object, you can see that the labels now are close to each other, but their scale hasn't changed. And actually, let's put them like twice as big to make them more legible. And let's say that we want the position not to be affected by the scale of the parent, so that they don't move when I'm going to resize it. Ah, yeah, okay, so the issue is that now I would have to scale all my other position. But if I were to change my scale of my character, now it's not affecting my debug output anymore. And same thing, if I were to set angular velocity of my object, you can see that the labels are now unaffected and they remain legible. But anyways, that's not what we want to do in this demonstration. It was just to show that label can be made more stable no matter what transformation are on the objects. The next thing we can do is we can push things a bit further, but before that we're going to like talk a bit about inputs because we're going to add a crowd because actually you know what, before doing the crowd we can actually do the rest of the debug. It's just not going to be very useful. We're going to do that in 2 steps. So let's say now I have those characters, and when they get outside of camera, I don't know where they are anymore. So what would be nice is to be able to actually have like a zoomed out version of the world and see where my characters are without having to render them. Because if I want to put that like in a corner of my screen, rendering the character is just going to be a mess of pixel. So for example, let's say I just want to see their name on this kind of debug. So the same way we did that, we're going to create another label. We're going to call it the character label. There we go. And you can see that on the character, we're going to add yet another child. So we already had the child for the animation one. We're going to remove all the layers, otherwise it's going to be very messy on screen. I'm just going to add another object called character label. And this object, this time I'm going to change its group. So instead of being in the same group as the rest of the object, which is the default one, because we didn't change it anywhere, we're going to set it in a group called overlay. And those names, it's the user that picks them. There's no predefined name beside the default one. So you're the one to pick whichever group you want. And I'll show why it's important. Let's say that we want it maroon, and this time on creation, we're just going to retrieve the name of the parent, the owner, sorry, and change our text with it. So basically, it's a bit like the label we've seen earlier in red, except that now this time it's color maroon. So if I remove the overlay and I start this again, we should see the name. It's exactly the same position as the animation. But if I put the group back, it's not rendered here anymore. It is not rendered at all, actually. It exists, but it is not seen by the camera because our current main camera only sees objects from the group default. So what do we want to do with this? And it's actually quite simple. We're going to render this information off screen. And to do this, we're going to create a new viewport. I call it label viewport. It's going to use a new camera called label camera. It's going to output on black. If I don't put the value of having a black viewport, the viewport will accumulate rendering every single frame. So it would be like like smearing a trail of rendering. But I want my viewport to be to clean the output destination every single frame. So I'm putting a black color on it. We don't have to do that for the default screen because by default the screen does this. But here we're going to actually render off screen in a different texture. And that's the next property called texture list. We're actually going to render to the texture called label texture. On that texture does not exist, it hasn't been created in code, but at the moment this viewport is going to be created, it's going to see that it needs to render to a texture named label texture. It's going to ask the texture module, do you know that texture? Texture module is going to say, no, I do not. So the viewport is going to create a new texture with that name and with a resolution that matches the camera that's been assigned to it. Here, the camera we assigned, we inherit everything from the main camera. I mean, that's going to be exactly the same properties, so like the same frustum and like the same everything. The only thing we're going to change is the group list. And here, the group list is what are the objects that are going to be rendered by that camera. And here we're going to say, I want to render the object from the overlay group. So this camera is only going to render objects from the overlay group and nothing else. And here you can put actually multiple groups. Like for example, if I were doing overlay and default, or actually maybe in the other way around, if I were doing default and overlay, that would mean to this camera, do first render pass of rendering all the default objects, then do a second render pass to render all the overlay objects. And you can add as many groups as you want. But in this case, we want our label camera to only render the overlay objects. So when we do this, we're going to render off screen to a label texture, but we first need to create the viewport. So that's what we're doing here on the scene. On the scene, I added an onCreate property. And what it's going to do is just going to create the viewport, label viewport. When the viewport is created, it's going to create the camera, and it's going to create the texture, and it's going to start rendering every single frame. So when we run mix and match, we don't see any different, but there's actually a texture that's been created off screen, sorry, and it's going to be rendered every single frame with the name of the object. So let's say, for example, I'm going to move the player one here, and I'm going to see if the texture exists. So I'm going to find label texture, and it says yes, it exists. So let's say, okay, I want to save the content of this texture right now. Actually, I can even use like label texture. It's true. So now if I'm looking at label texture on disk, we can see that an image has been saved. And if I open it, we can see that we see the two labels that have been rendered by the object, where the parent is. So the player one was at the bottom and the player two to the right, and nothing else on this texture. So right now, it's fine because we have like our debug overlay, but we are rendering it off screen, and it's not very convenient to save the texture manually to see what's going to happen. So what we're going to do is that we're going to create yet another viewport to render it on top of our current viewport. And so that's what we're going to do here. Let's quit this. And for this to happen, we're just going to create a debug viewport. This debug viewport tell it to render in alpha blended mode. This way we'll have it doing transparency on top of our current rendering instead of being like completely black. I'm going to tell it I want you to cover a quarter of the horizontal size of the current viewport, the current texture, and a quarter of the vertical size of the current texture. The current texture is the screen for this viewport because I didn't put any texture list. I want it to be on top right, so it's going to be like a small rectangle to the top right. And I'm going to use a shader on it. And the shader is going to be itself. The shader is going to use only one single parameter that I named text, and text is going to be our label texture. So this shader is going to use the label texture that is rendered off screen as an input. And what it does, it's very simple. It simply samples the content of that texture, retrieve the RGB component, and render it with half transparency. So now all we need to do is create that viewport on top of the rest. So we can see that this time on scene, instead of just having like a label viewport, I'm actually creating first the label viewport and then the debug viewport, which is the second one. And if I run this, we can now see, oops, that's the wrong thing. I don't need that texture anymore. Now if I run this, we can see at the top right our debug information, but it's tiny right now because our objects are very small, and but you can see it's player 1 and player 2. So we're going to change this. We're going to say that our label object, which is here, we're going to give it a scale. There we go, okay, scale 2. And we're also going to ignore from parent the scale of the parent, and hopefully it should be large enough now. Oops, what did I make? Character label, ignore from parent scale. Scale equal to current on create. I don't see what oh yeah, because the parent was already 2, so it should be 4 this time. Yeah, it's a bit bigger now. Let's even go to 8. There we go. Now we have the big names and we can have our debug information. But our goal was to render like the world around our character even if they go off screen. And you see right now it matched 1 on screen, and that's normal because our label camera is inheriting everything from the main camera, so it sees exactly the same thing. So we're going to change this. And this time, our label camera, we're just going to say, okay, I want you to zoom back like a quarter time, so it's going to see 4 times more. And you can see now that they are a bit too small now again, so let's just put it back to 16. And you can see that now if I go off screen, we can still see the world around, and I can navigate my player 1 and see where it is. And this debug can be useful. So right now we only have like 2 characters, but imagine we have a crowd or thing like this. We could see which objects are placed where around the camera, and we can do that with any kind of like runtime information. Like for example, on Little Cell, we have like real-time shadows, and in my debug output, actually maybe I will be able to start this. this one, yeah. So in little cells, you can see that two rectangles at the top right, and it's the same thing, it's the same idea, except that this time I'm rendering the occluder map, which is the first rectangle here, and you see it's just a white shapes of everything that can occlude the light, and when I have the mean to create a white cell, which is going to have a dynamic light, and for this I need to make a few points, so won't be too long. Oh, there we go. So now I have a light here, and when I'm going to create a light, it's going to cast shadows dynamically, and sorry, I'm just going to, there we go. It's going to cast shadow dynamically, and we're going to see the projected shadow here. So, and you can see at the top right, we can see the debugging real-time shadow texture. So that was very useful for me when I was actually coding the real-time coding the real-time texture projection. This way I could, even if it was not working anything like this, I could see the intermediate texture and see what was going wrong with it. Because those are two intermediate textures that are not rendered on screen, but are used by the compositing at the end. And being able to see their content on the fly at runtime was very useful. And these debug also are just part of a dev.ini. If I were to remove that dev.ini file, the game would start without them. And actually, we can easily see this by going to little cell, which is here. Oops. And we can see that there's a dev.ini. If I rename dev.ini, like this, for example, and I start the game again, you can see that the rectangles at the top right are not here anymore. We don't have our debug information. And the player, it's exactly the same build that is going to ship to the player, except that on my end, I have the dev.ini that adds a bunch of cheat codes and like the debug texture that you've seen, which is these two rectangles. So going back to our demonstration, sorry, I'm going to plot this. What we're going to do now is that we're going to use our debug not with name, but maybe something that is a bit more useful if we have a crowd. We're going to use something like a square. Let's change it. So our character label, I'm going to keep the name even it's not going to be a label anymore. It's not going to be a label. It's going to be, let's see, it's going to be to have a graphic which is going to use a pixel texture, and it's going to be a square of 10 by 10. That's 10 by 10. And let's see, the rest is the same thing. We don't need this anymore. It's just going to be a square. It's going to be maroon. And let's see if I did that correctly. There we go. Yeah. So now we can see two little square for our characters. So before going further for the debug, we're going to talk a bit about inputs right now. So right now you can see that we have physical inputs, like player 2 is using physical inputs. I mapped it to my second controller or to the arrow keys, and the player 1 is mapped to WASD on my first controller. Of course, those mapping can be changed on the fly, but that's not what I want to illustrate today. So what we're going to do is we're going to create NPCs, and we are going to inherit from the current class, the current character class. If we remember from the last time, the character class didn't have much in its code. All it does at the creation, it enables its current input set. It's face down, and then the code itself is just activate the current input set, retrieve the input, move right, move left, move up, move down, create a vector out of it, check if the run input is active or not. If it's run, we're going to use the run animation, otherwise we're going to walk animation, and same for the speed. We're going to change our character into from Cartesian coordinate to spherical. We're going to change its row component based on the speed defined in config. So like idle speed is 0, run speed is, I don't know, X, and walk speed is Y. It's going to retrieve this information and put it in the row component of the move. It's going to change the orientation based on the theta angle. and it's going to be like in 8 quadrants, and it's going to transform the vector back into Cartesian to apply it as a spin. And lastly, we're going to use the name we found here to play the animation. So it's going to be either idle, walk, or run, followed by the name of the orientation from the quadrant we define based on the theta angle here. And then we're going to put back the previous input set that was active. And here it's a bit of code just to make sure that the characters are seen like a single entity and not just like a layer that can mix and match between players. All I do is that I take the Z position and I do the reverse of the Y position. So the lower to the screen, the closer to the camera you get. And that's it. That's just for this. That's the reason for this 4 lines of code. And that's it for our code. So every character are going to run this code here. And every character is going to check for this input here. Move right, move left, and so on and so forth. The thing is, those inputs by default are just virtual input. And unless you bind them to physical output, they will remain virtual, and only virtual. And the way we bind them in physical here is that by saying that the player 1 is going to use the key WASD for move up, move left, move down, move right, and same thing for the player 2 is we're using the keys. And because we bound physical output, those are going to be pulled by the engine every frame, and they're going to apply to the virtual input of the character. And that's how I can actually move separately 2 characters with the same code without having to deal with any player-specific things here. All I'm going to take right now is select the input set of my character, and just poke the name I chose. Those names are just chose not randomly, but Orx doesn't know anything about the names. They only mean something to me. That's why I name them move right, move left. And here I'm just binding them with the same name to physical inputs. If I do not do this, but I actually have like a character, so let's see if I have a copy paste ready for this. I believe I do have something like this. And no, I don't anymore. So what we're going to do is we're going to create a character called NPC, and NPC is going to inherit from character, from male character. We want a male, and when I'm going to create that guy, and I'm going to create in command here, so like object create NPC, it's here and it has its own set of virtual input, but they are not bound to the current physical input. So I can activate them either in code or through command by just pushing his input set and pushing the buttons. So let's push this logic a bit further. What we're going to do now is going to have like an NPC class, and it's a very simple class with like 3 methods in it: create, delete, and update. And I'm going to add the variable that's called a timer. And what I want that NPC to do is having a very simple brain, like a monkey brain, and every time the timer expires, it's just going to randomly press on the buttons that I've defined. So move right, move left, move up, move down, and run. And every time the timer expires, it's just randomly going to press buttons, and it's going to give a life to that character. So in order to do so, I have a class here. So we can see here that NPC inherits from the character class. So here in NPC, on the creation, I call the parent function for creation. I set my timer to 0, and I deactivate my input set. That means that I do not need to pull the input set for this character, and that I am not binding it to any physical input, so there is no reason to keep pulling it every frame. It's basically like an optimization. Especially if I want like hundreds or thousands of characters, there is no point of pulling hundreds or thousands of input sets if they are not bound to anything. So that's what I'm doing here. I'm just disabling it. Delete, it's simply the same thing as the parent. I could actually have like completely removed the undelete. I put it there in case I had something to do, but I don't. And the update function is going to be very, very simple. So we're going to update the timer based on the current DT of the frame. And every time the timer crosses the 0 threshold, we're going to push our current config section. We're going to retrieve a new value for the timer. That means that in my NPC here, I would have to have like a timer value. I'm going to say I want my timer to be a random number between 1 and 4. So that means every 1 to 4 seconds is going to go in that if section. We're going to select its input set, and we're going to set a permanent value for the input based on the random between 0 and 1. So randomly, I'm going to push on right, left, up, down, and run. And I'm restoring the previous input set, getting out of the config session, calling the update from my character, which is going to use the input that we defined to actually move the character and play as the animation. So this brain is really basically those 5 lines of code, and it's very simple and just pressing buttons randomly. So now I need to register that class so that it's going to be created every time I want an NPC. And to do this, here there's a section, because I'm using scroll, there's a method called bindObject. And that's where I say that I bound the character to the character section. And here I'm going to bind the NPC class to the female NPC as well to the male NPC. So that's what I'm going to do in config. Instead of calling it NPC, I'm going to call it male NPC because it comes from male character. I'm going to do the same with the female one coming from female character. So I have my 2 base NPC classes. If I were to create those, they are going to move randomly now. So if I start the game here and I'm going to create like the male NPC, you can see that every 1 to 4 seconds is going to randomly press buttons and like do things. And same thing if I'm doing the female one. There she goes. And she's going to randomly press the buttons. Those characters are still using random layers, and they're just going to live their lives. And you can see that they are going off screen, but because of the debug, we can actually track them. But right now, everything is like using a red maroon square. So let's change this. So our debug here, if we remember, we add the maroon color here for all the characters labeled. Let's say that now I don't want this color for everyone. I'm going to retrieve the color from the parents. So a bit like we did earlier for the different layers. So let's say that I'm going to add like I want the female NPC to have a label color that is, I don't know, like sky blue. And I want the male NPC to have a label color that is green. And let's say that I'm not going to put one here, I'm going to put one on the player one. I want player one to have a color of, I don't know, like player one is going to be white, and player two is going to, I don't know, yellow. And so, because now I defined the color in the label, we will have to do the same thing as before. So on the creation of my label, I'm going to get my owner. I'm going to get its label color, and I'm going to set the color of my object with this. And if I didn't make a mistake, we should, we don't have NPC. They are white, so I made a mistake because it didn't take the yellow one. Let's see what I did. Actually, you know what? I'm going to compare it because I'm not trusting myself with copy paste right now. I mean, with non-copy paste right now. So label color, layer label on create, get owner, get name, get. What did I make as mistake? Let's see. I'm sorry. Character label. Get owner. Oh, yeah. No, actually, I don't. What? This is the owner's label color. I didn't make a typo. Was it actually yellow? Let's do red to see if it was working, and maybe I didn't see it. No, it's not working. So let's start the debug version 1 and timeline trying in your okay, that's not what I want. Again, I'm just going to go back to my copy paste because I'm too tired to do it live apparently. But I don't see, if you see the issues, just let me know, but I don't see it. I'm trying to speak at the same time and trying to debug. It's not helping much. So let's see. I'm going to copy paste the old track I had and see if it works. So sorry, I have 2 virtual screens and only 1 monitor, so it's not easy to do this. So if I were doing this, I don't want to have the name this time. I don't want to have this. I just want to get the label position. Oh, did I forget to get the name of the object? Yes, I totally forgot to get the name of the object. That was my mistake. Yeah. Okay, so actually, sorry about that. Yeah, here I'm getting the GUID of the object, and I forgot that I want to get the name of the object. Get name. Yeah, there we go. So sorry about this. I'm a bit tired. So right now we can see. I'm just going to go back to the release one. There we go. So we can see player 0, player 1 as a white one, player 2 as a yellow one, and if I create a male and NPC, you can see one as a light blue one and the other one as a green one. So if I were to create multiple of them, they would reuse the same color, and so that's actually easy to see what's going on. But you can see that they're all moving at the same time, and it's because their current input set is linked to their section name. And because right now I created 3 instances of the male character, they are sharing the same brain. So basically, that's one brain to control all of them, and that's not what we want. So one easy way to do to fix this is to give them a random name at generation. Of course, if you had like already like a map, maybe you, I don't know, you have like a Carl and Mike, and they are all different sections, and they all would have their different inputs. But what I can do is simply create a spawner, and that spawner is going to generate them. So I'm going to put here. We're going to create a spawner. That spawner is going to create either a male or a female. And you can see here the section is called NPCs. It's because I'm going to fetch that section in the object. So instead of having object male and female NPC, and I would have the same issue, like I would have X male and Y female, and they would all move at the same time. What I'm going to do here, I'm going to get the current section, I'm going to get randomly male or female NPC, and I'm going to get a random number between 1 and, I don't know, like a large number. And I'm going to set a new config section named npc dash the random number I got, and I'm going to use the parent either the female or the male one. So basically, I'm going to randomly generate new section at runtime, and they're all going to have their separate brain. Let's just generate 50 to begin with, and we're going to like create all 50, maybe not at once, like 1 per frame. And on the scene, we're going to say I want my NPC spawner as well. So if I didn't make a mistake this time, there we go. All our little characters, they're going to take a while because they all are random, using random layers, so we have a lot of variations, but those textures are huge, and they actually use gigs of video RAM, so it takes a few seconds to load them, decompose them into video memory. But when it's done, everything is working as intended. So you can see that right now, we have on screen a bunch of characters, a lot of NPCs, and on our debug on top right, we can see that all the green ones are the male ones, the blue ones are like the female ones, the white one is my player 1, my yellow one is the player 2. And they've been created with different input sets, so they are not moving all at the same time. They are moving like completely independently. And let's actually put like a bunch more. Like we're going to have 500 of them. And now we're going to. What did I make a mistake here? Oh, I changed the delay. No, I don't want to delay. I actually want the delay to be this, but I want to create 10 by 10. Okay. There we go. Because we create them all at the same position, it makes a kind of weird pattern being created, and then they're going away, but that's not what we want. So what we want is to give them like a starting position. So instead of being all in 0, 0, they're all going to be in between, let's say, LCDs. They are all going to be minus 2000 and randomly by a step of 100. So basically, like we have a grid which size of a cell is 100 by 100. I want random until 2000, 2000. That should spread them out a bit. And we have a timer, and here we can just use the male version. So same for position, we're going to use the same value as the male one. And now when we create them, they should, there we go. We have like a distribution on a square of 4000 pixel by 4000 pixel wide, and it's basically like we have a crowd. And actually, you know what? I don't see the FPS. It's because we have the we have the debug. So here, if I say debug viewport, I say no debug, and same for the label viewport. So now the FPS should be no, it's not no debug. I thought it was no debug. Creation. Sorry, I'm going to ask my cheat sheet creation template, and it's called yeah, no debug. Cool. What did I do here? No debug. No debug. Okay, I'm not sure why this is not working. No debug. Anyway, so we don't see the. Oops. Sorry. We don't see the FPS, but normally it should be like first at 50 something until all the texture are loaded in memory, and then it should be like 60 FPS no matter how many objects we have. Actually, a better way to see that is to start the profiling version. If we start the profiling version, and here we can see that it takes like a lot of work at the beginning because we're streaming a lot of texture. We actually decompress in memory 5.85 gigs of texture. Those are really huge, and we have like 100. They are all 60 megabytes texture, and we have like 105 of them, so it takes a lot of space in memory. But when it's done, we are at a steady 60 FPS, and we can actually see that our update for the object is about 2 milliseconds on my machine right now. Yeah. No, sorry. Yeah, that's it. Update is 2 milliseconds. So that's basically the blue purple here. So even with like 500 NPCs randomly pressing button on 500 different virtual input sets, the frame rate is not taking a dip or anything. But that's not the most efficient way of like simulating a crowd, of course. But even by doing a naive approach that is entirely data driven, because we have not changed our code since we have our NPC class, we can have a crowd like this. And the debug can be used for like more advanced things. Like right now, we can actually see the female versus male population and the player wants. But let's say that in our gameplay we have an assassin, and the assassin is going to be assassin. It's going to be a male NPC, and nothing will like actually. Let's say that the only thing that tells him apart is that he has a bright sword. So male weapon, bright sword. Oops, bright sword. And we are going to add it to the list of things we spawned at the beginning. So now we do have an assassin, but we don't know where it is in the crowd. And as we can see, there can be multiple people with a bright sword, so we don't know which one is the assassin. But like we did before, how about we cheat? In our dev.ini, we're going to say that the assassin, as a label, is going to be red. And now if I start it again, we can see on the map, the assassin is up there. But if I move out of screen, we don't see myself anymore. So what we're going to do is, first of all, let's not have like that many, just spawn 50 of them. And wave delay, wave size, let's spawn all of them at once. And we're going to change a bit like our gameplay here. We're just going to say that our main camera, our player one, when it's getting created, it's going to find the current camera, the current main camera. So camera.find main camera, and it's going to set itself as a parent of it. So camera.setParent myself, and the main camera is going to ignore from the parent. Ignore from parent. It's going to ignore the scale and the rotation. So now if I have this, oh, I made a mistake again. Oh, it's better last night. So camera finds main camera. Well, you know what? Let's do it live this way. So camera finds. It's not find, it's get. See? Get. Because there's only one camera with a name. There we go. So now we can see that when I move the player one, the camera is set on top, and because I ignore the scale and the rotation, the zoom won't be affected, anything like this. And we can see that if we move, now we find our assassin, and that's this guy here. This is our assassin. Even though this one also has a bright sword, we know that this is our assassin. Actually, let's make it more obvious. Let's say that our assassin is going to have a weapon called the assassin weapon. So assassin, it's weapon that here we say that the weapon was a male bright sword. We're going to override that. We're going to say that the weapon, only in debug, so it's not going to ship, but it's going to be the assassin weapon. Assassin weapon. And the assassin weapon, it's going to inherit from the male bright sword. Oops, male weapon bright swords, but it's going to use a shader, and we're going to call it the red shader. And the red shader, it's going to use one parameters only, which is like texture, and we're not going to define text, means that it's going to use the texture of the current object, and the code is going to be code void main. So I want the frag color to be vector 4. I want it to be bright red, so 0.0, 0.0, oops. And the alpha is going to come from the texture itself. So texture 2D, shell text coord 0, xy, and shell text alpha. Okay, we have no two time, and this is going to work. Let's see. Finish loading, please. Where are you? Oh, you're there. And I made a mistake, so again, sorry about that today. Varying depressing gobbler deprecated, unable to find texture 2D vec2. Okay, so I made a mistake. It's because I forgot to name the texture in my shader. Sorry. Too tired today. Thanks. Oh my, oh my, oh my. Okay, let's see now. Do you have a red sword? Yes, you have a red sword. So we made it more obvious. We changed the debug information directly on the mesh itself. We replace the shader, and it's only going to be replaced when the dev.ini file is local. And that's how we can identify our assassin. We could actually put the red shader on everything in arms and not just like the weapon. But here it's an easy way to visually see it. In addition to like the map itself. So we are all outside of the map right now, but we can see the red dot on the map and we can see the red weapon in game. And this is only in debug, meaning that if the content of the dev.ini file is not here, let's rename it, and we start the game is just normal. There's an assassin somewhere, we don't know where it is, and it's going to have a yellow sword, but like not a specific red one. So yeah, and I believe I spoke a lot already and made quite a few mistakes. I apologize for this. But if you have any question, now is a good time. And also I'm going to check Discord to see if someone actually typed something. No. Well, that was it for the debug and virtual inputs. Again, the fact that we can override anything in config, and let's put back the name so that The fact that we can override any properties locally and not something that's going to be part of the build, not something that requires any code changes, is very powerful to debug and to add like cheats and things like this. Often, like you have to put like your in traditional game development, you put your cheat in code, and you forget to disable it in code when you make your build that ships. Well, some games ship with cheats that should not have been there. Of course, some cheats are meant for the player, but the dev cheats, usually they should not be meant for the player, but it happened that they ship. With this approach here, because the dev.ini is not part of the packaging at all, there is no way that you can actually ship anything that is not intended for the player. So you can override anything, any like properties, and because everything is data driven, it's very powerful to do. And of course, when you do it and you're not trying to speak at the same time and you're not underslept, you probably will have a better mileage than me today in this video. So if you do not have any questions, I thank you for coming, and I will wish you a good evening. Thank you, everyone. Have a good one.